Okay, so today we're going to be doing section 5.7, which is all about the natural logarithmic function. So in 5.5, we spent a lot of time focusing on u substitution and figuring out what our u is going to be. And we've already had a few problems that have natural log in them, but this section focuses totally on that. So in our case, we want to figure out what's our u value. And in a fraction, we've discussed this before, let's make the denominator our u function. So when I'm writing this out, we're going to let u be equal to 2x. And then the derivative of that would be 2 dx. So whenever we're trying to replace dx, we're looking at what do we already have in the problem, but we don't have a 2 anywhere. So this is where we move the 2 to the other side by dividing it. And really, we can rewrite that as 1/2 du equals dx. So I now know what I can replace that with. Dx is going to be replaced with 1/2 du. So when I go to rewrite this integral, I'm going to move my 1/2 to the front because it's a constant. And then I can write 1 over u. We've already discussed that 2x is going to be replaced by u, and our du. So a couple of things to remember. When we do the process of integration, our du drops out because we're going to the original function, we're doing the antiderivative. And we have the formula that the integral of 1 over u is the natural log of the absolute value of u. And then we put that plus c because, again, we don't have any bounds to find the area. So then the last thing we should do is instead of the u, we're going to substitute that u value back in and write 1/2 times the natural log of the absolute value of 2x plus c. So that becomes our final integral. So we're actually doing the same thing in example 2. This time we've got the integral of trig functions, secant squared x over tangent x dx. Well, we already know our u needs to be the denominator. So the wonderful thing that's about to happen is if u is tangent of x, the derivative of that is secant squared x dx. Well, it's already right there. We don't have to do any kind of distributing, evaluating, dividing, or anything. So when I go to rewrite this, my secant squared x and dx just gets replaced by du. And on the bottom, we've already said that tangent of x is u. Well, this is the exact same formula that we are applying. 1 over u du is the same thing as du over u. And the integral of that is natural log of the absolute value of x plus c. Well, we already know that x or u is going to be replaced by that tangent of x. So once again, our final answer is natural log of the absolute value of tangent of x plus c. Okay, let's do one more just like this before we get to something a little bit more complicated. In example 3, we've got 3x squared plus 1 over x cubed plus x. So our u value is still the denominator. The derivative becomes 3x squared plus 1 with that dx. So we've already got everything taken care of. So this really turns into a problem that looks just like examples 1 and 2. I can rewrite this as du over u, which is the natural log of the absolute value of u plus c. So once again, we were able to plug the u value back in. So u is x cubed plus x. And don't forget that plus c. All right, the last example is going to require the most work here. So let's turn the page and go to example 4. So this time we've got a fraction that has x squared plus x plus 1 over x squared plus 1 dx. So we know that the denominator needs to be the u value. So if I do this with x squared plus 1, my derivative is 2x dx. Now, if you're looking up here, that is nowhere to be found. So we have to apply a new strategy first. Okay, our new strategy is to use long division first. So we're going to break up this fraction so we can really use U substitution and apply this and get a specific answer. So here's what we're first going to do. We are going to divide x squared plus 1 into the numerator. X squared plus x plus 1. And so long division tells us first thing we're trying to do is how do we get from x squared to x squared? Well, we're really just multiplying by 1. So I multiply this 1 by both of these, x squared, and I'm going to move the 1 over here so it's underneath the right term. Okay, so what we do next is subtract them. Our x squareds cancel, 1 minus 1 cancels. Here's what we bring down, just the x. Well, because I can't go from x squared to x, the x becomes my remainder, and what we do is divide by what we were dividing by, the x squared plus 1. So let me write out, that's our remainder. Okay, so with this 1 and the x over x squared plus 1, we can now rewrite this integral. I haven't done any integration yet. All I'm doing is just a rewriting. So this turns into the integral of 1 plus x over x squared plus 1. And this is all dx. So now the next question is, how do I do U substitution? I have a 1 and I have this fraction. What we can now do is, because of the plus sign, break this up into two integrals. So now I'm going to write this like this, the integral of 1 plus the integral of x over x squared plus 1. So I'm going to do a little bit of work here for U substitution. We already know the integral of 1 is going to be pretty easy, so we'll write that out in just a second. But our U value is the denominator, x squared plus 1. The derivative is going to be 2x dx. We have the x, we have the dx, but we unfortunately don't have the 2. So we will divide that over here. So 1/2 du will become x dx. All right, now let's move all of this work over here. I'm going to write this out. The integral of 1 is x. Let's just draw a little arrow so we don't forget what we're doing there. Then let's go ahead and rewrite the integral with our du's and the 1/2. So the 1/2 can go in front of the integral. And then this now becomes 1 over u du. X and dx are going to get replaced with our 1/2 du. So then when we apply this, we've got 1/2. The integral of 1 over u is the natural log of the absolute value of u plus c. We have one more thing to substitute in. We're going to plug in that u value. That u value is x squared plus 1 plus c. And that becomes our final answer.